So welcome back to the continuation of our tutorial series on deploying a machine learning model on Kubernetes. In this part, we will be seeing a few other Kubernetes commands to debug the deployment issues, and also we'll discussing about optimizing the resource allocation and scaling strategies. And now we have several other commands that we should be aware of. We can check if the pods are running and ready, like using this command. Let me clear this. So this command retrieves the list of all ports associated with the ML services. So in our case, we have three replicas of an application which is running. So the output just displays the status of each pod and including whether it is running, bending, or in a failed state. So in our case, it's running. So if the ports are not ready or stuck in a non-running state, then this is the first step to identify the issue. Okay, with your running service. And we can also do describe command. Okay, for example, so this command kubectl describe pod with the pod name. So this command provides a detailed information about a specific pod, such as events, container, resources, and status condition. And if the pod is not starting, and this command will help to identify the root cause, such as resource limits, permission issues, or other errors in the pod setup. And we can use as well kubectl log, and this command which shows the logs of the specific pod, and if the pod is running but not behaving as expected, the model is failing to load, for example. So inspecting the logs can help us to diagnose the issues such as configuration errors or runtime exceptions. So in our case, it's running properly, so we are getting 200. For example, if your model loading is failed, okay, for example, so this command kubectl get pvc, this command checks the persistent volume claims, and pvc is used for so this command will check the status of the persistent volume claims, and pvcs are used for persistent storage, and our ml service is likely depend on one to load the model. So if the model fails to load, the issue might be related to a pvc not being correctly bound to the persistent value. So this command will show all our pvcs and their statuses. And we can do as well kubectl describe pvc, I mean the name of our pvc. So this command provides the detailed information about the specific pvc. Like in our case, it will shows the status and events. It helps to check if the pvc is currently bound to the persistent volumes and whether it is able to provide the necessary storage for the ml model. So if your HPA is not scaling properly, then you can do this command. Let me clear this. So this provides the details about the Horizontal Pod Autoscaler associated with your ML service, and it shows the HPA configuration and the metrics it is using to scale the number of ports. And if the HPA is not scaling as expected, this command can help determine whether the target metrics like CPU utilization are being met, or if there is an issue with the HPA configuration or not. So for example, if the matrices are not showing in the Prometheus, for example, as we have already put forward our Prometheus here. So once we have put forwarded to Prometheus, we can open the web UI and navigate to the target as I showed earlier. This will show the list of targets. So if there is any issues or the state is down, it will show the error message here, and you can debug accordingly as well. To check the Prometheus log, basically you can use this command. Let me go back here and kubectl logs log level with app Prometheus, it shows the logs of the Prometheus port. This is filtered by the app Prometheus label, as you see here. So if there is an issue with Prometheus scrapping matrices from ML service, or if the Prometheus itself isn't it functioning properly, reviewing these logs can reveal some error messages or warning. So that's it, guys. We are at the end of this part. So far, what we have done is we have tested and try to debug the Kubernetes deployment issues, and also see how to optimize the resource allocation and scaling strategies. And congratulations for finishing this course, and you have successfully completed this end-to-end tutorial series on deploying a machine learning model on Kubernetes with auto scaling and monitoring. This was a deep dive into the containerizing the ML deployment, covering everything from model training to deployment, scaling, and observability. So throughout this journey, we explored several key concepts and technologies, ensuring you gain hands-on experience. For setting up the deployment environment, so we have configured our environment with Podman or Docker and Kubernetes with kind, and installed all necessary dependencies. So this foundational step prepared us for subsequent stages of development. And also we have been building a machine learning model and API. We trained a sentiment analysis model using Scikit-Learn and developed a FastAPI-based REST API to serve predictions. We also ensured the API was functional by testing it locally. And then we have containerized the ML API. So we have created the Docker file, build a container image and ran it locally to test its functionality. And this step ensures that our application was portable and ready for deployment. And then we have deployed everything on Kubernetes. We have created the kind cluster, which is Kubernetes in Docker cluster, and we have wrote essential Kubernetes manifest files like deployment, service, config map, PVC, and applied them to deploy our ML service. And we have also implemented auto scaling using Horizontal Pod Autoscaler, which is HPA. We ensured that our ML service could dynamically scale based on workload demands and improving the performance and resource utilization. And we have also added monitoring service with Prometheus. We integrated Prometheus to collect and visualize the performance metrics and providing the insights into the resource usage, request rates, and system health. And finally, we have explored different ways to test API endpoints, debug the deployment issues, and also how to optimize the resource allocation for better scalability. So far, we have built a fully functional, scalable, and monitoring machine learning deployment, which is crucial for setting up and deploying a real-world AI application in production. If you found this tutorial helpful, then do subscribe to our channel. In the way, you will be get notified whenever I upload a new tutorial. So until then, this is Abonia. See you all in our next session. Thanks for watching.